Good morning, everyone. My report for today is about steam power plant. So what is a steam power plant? Steam power plant is a type of power plant in which the prime mover is steam driven. Water is heated, turns into steam, and spins a steam turbine which either drives an electric generator or does some other work like ship propulsion. After it passes through the turbine, the steam is condensed in a condenser and recycled to where it was heated. This is known as a RANKINE cycle. The greatest variation in the design of steam power stations is due to the different fuel sources. Some prefer to use the term energy center because such facilities convert forms of heat energy into electrical energy. Two types of steam power plant. Number 1. Central stations. The power of this type of power station is produced for sale to the general customers, and its overall management is vested with a central person, group, or organization. Industrial power stations. This type of power station is what production company generates. Steam power plant consists of boiler, superheater, steam turbine, generator, condenser, economizer, feed pump, cooling tower, and chimney. Boiler. The purpose of the boiler is to convert water to steam. The steam may emerge wet, dry, saturated, or superheated depending on the boiler design. Thermal electrical power generation is one of the major methods. Superheater. The steam is taken out from the boiler and is superheated so that the steam should be free from the water molecules. Steam turbine. A steam turbine is a mechanical device that extracts thermal energy from pressurized steam and converts it into rotary motion. It has almost completely replaced the reciprocating piston steam engine primarily because of its greater thermal efficiency and higher power-to-weight ratio. Generator. A generator that converts one form of energy to another is attached to the rotor of the turbine, and as the turbine rotates, it also rotates with the speed of the turbine. Condenser. The main purpose of the condenser are to condense the exhaust steam from the turbine of reuse in the cycle to maximize turbine efficiency by maintaining proper vacuum. Economizer. The economizer adds the feed water to extract a part of the heat from the condensate by increasing the feed water temperature. Feed pump. This feed water is to be sent to the boiler using a feed pump only. The cooling tower. The water that is used to condense the steam in the condenser was supplied from the cooling tower. Chimney. It is the last stage where only the air particles will enter into the atmosphere by reducing the heat from the steam by the usage of the water sprinklers. Components of steam power plant. A. A furnace to burn the fuel. B. Steam generator or boiler containing water. Heat generated in the furnace is utilized to convert water into steam. C. Main power units such as an engine or turbine to use the heat energy of steam and perform work. D. Piping system to convey steam water. The flow sheet of a thermal power plant consists of the following four main circuits: feed water and steam flow circuit, coal and ash circuit, air and gas circuit, and cooling water circuit. The schematic and TS diagram of the ideal reheat Rankine cycle in the steam power plant. The ideal reheat Rankine cycle differs from the simple ideal Rankine cycle in that the expansion process takes place in two stages. In the first stage, the high-pressure turbine, the steam is expanded isentropically to an intermediate pressure and sent back to the boiler where it is reheated and at constant pressure, usually to the inlet temperature of the first turbine stage, steam then expands isentropically in the second stage or the low pressure turbine to the condenser pressure. Different types of system and components used in steam power plant are as follows. A. High pressure boiler, prime mover, condensers and cooling towers, coal handling system, ash and dust handling system, drought system, feed water purification plant, pumping system, air preheater, economizer, superheater, and feed heaters. This figure shows a schematic arrangement of equipment of a steam power station. The coal received in coal storage yard of power station is transferred in the furnace by coal handling unit. The heat produced due to burning of coal is utilized in the converting water contained in boiler drum into steam at suitable pressure and temperature. The steam generated is passed through the superheater. Superheated steam then follows through the turbine. After doing work in the turbine, the pressure of the steam is reduced. Steam leaving the turbine passes through the condenser, which is maintained the low pressure of steam at the exhaust of turbine. Steam pressure in the condenser depends upon flow rate and temperature of cooling water and on effectiveness of air removal equipment. Water circulating through the condenser may be taken from the various sources such as river, lake, or sea. If sufficient quantity of water is not available, the hot water coming out of the condenser may be cooled in cooling towers and circulated again through the condenser. Bled steam taken from the turbine at the suitable extraction points is sent to low pressure and high pressure water heaters. Air taken from the atmosphere is first passed through the air preheater, where it is heated by flue gases. The hot air then passes through the furnace. The flue gases, after passing over boiler and superheater tubes, flow through the dust collector and then through economizer, air preheater, and finally they are exhausted to the atmosphere through the chimney. Steam condensing system consists of the following: condenser, cooling tower, cooling water, hot well, condenser cooling water pump, condensate air extraction pump, boiler feed pump, and makeup water pump. Steam production. Boiler is an apparatus used to produce steam. Thermal energy released by the combustion of fuel is transferred to water, which vaporizes and gets converted into steam at the desired temperature and pressure. Boiler is a closed vessel in which water is converted into steam by the application of heat. Usually, boilers are coal or oil fired. The steam produced is for producing mechanical work by expanding it in steam engine or steam turbine, heating the residential and industrial buildings, and performing certain processes in the sugar mills, chemical, and textile industries. There are two types of boilers. First is a water tube boiler. It circulates water through the tubes and hot products of combustion flow over these tubes. Water tube boilers require less weight of metal for a given size, are less liable to explosion, produce higher pressure, are accessible, and can respond quickly to change in steam demand. Second, the fire tube boiler. The hot products of combustion pass through the tubes which are surrounded by water. Fire tube boilers have low initial cost and are more compact, but they are more likely to explosion. Water volume is large, and due to poor circulation, they cannot meet quickly the change in steam demand. Advantages of water tube boiler. It has a high pressure that can be obtained. Heating surface is large, therefore steam can be generated easily. It has a large heating surface that can be obtained by using large number of tubes. And because of high movement of water in the tubes, the rate of heat transfer becomes large, resulting into a greater efficiency. Advantages of fire tube boiler. It has a low cost. fluctuations of steam demand can be met easily, and it is compact in size. Major components of steam power plant and their functions. Number 1. Economizer. It is a feed water heater deriving heat from the flue gases. The justifiable cost of the economizer depends on the total gain in efficiency. In turn, this depends on the flue gas temperature leaving the boiler and the feed water inlet temperature. Number 2. The air preheater. The flue gases coming out of the economizer is used to preheat air before supplying it to the combustion chamber. An increase in air temperature of 20 degrees can be achieved by this method. The preheated air is used for combustion and also to dry the crushed coal before pulverizing. Number 3. The soot blowers. The fuel used in the thermal power plants causes soot, and this is deposited on the boiler tubes, economizer tubes, air preheaters, and etc. This drastically reduces the amount of heat transfer of the heat exchangers. Soot blowers control the formation of soot and reduces it to corrosive effects. Number 4. Condenser. The use of condenser in a power plant is to improve the efficiency of the power plant by decreasing the exhaust pressure of the steam below atmosphere. Another advantage of the condenser is that the steam condensed may be recovered to provide a source of good pure feed water to the boiler and reduce the water softening capacity to a considerable extent. Number 5. The cooling tower. The importance of cooling tower is felt when the cooling water from the condenser has to be cooled. The cooling water after condensing the steam becomes hot, and it has to be cooled as it belongs to a closed system. The cooling towers do the job of decreasing the temperature of the cooling water after condensing the steam in the condenser. Number 6. The superheater. It consists of a superheater header and superheater elements. Steam from the main steam pipe arrives at the saturated steam chamber of the superheater header and is fed into the superheater elements. Superheated steam arrives back at the superheated steam chamber of the superheater header and is fed into the steam pipe to the cylinders. Number 7. The reheater. The reheater functions similar to the superheater in that it serves to elevate the steam temperature. Primary steam is supplied to the high-pressure turbine. After passing through the high-pressure turbine, the steam is returned to the boiler for reheating, after which it is sent to the low-pressure turbine. Calculations. A steam power plant uses steam at boiler pressure of 150 bar and a temperature of 550 degrees Celsius with reheat at 40 bar and 550 degrees Celsius at condenser pressure of 0.1 bar. Find the quality of steam at turbine exhaust, cycle efficiency, and the steam rate. The givens are: pressure 1 is equals to 150 bar, temperature 1 is 550 degrees Celsius, pressure 2 is 450 bar, temperature 3 is 550 degrees Celsius, pressure 3 is 0.1 bar. The required values are the quality of steam at turbine exhaust, the cycle efficiency, and the steam rate. Solution. First, we will find the quality of steam at turbine exhaust. We will find first the properties of steam using the steam table. At 150 bar, the enthalpy 1 at 550 degrees Celsius is 3,445.2 kJ per kilogram. The entropy at 40 bar is equals to 6.5125 kJ per kilogram Kelvin at 550 degrees Celsius. The enthalpy 3 is equals to 3,558.9 kJ per kilogram, and the entropy 3 is equals to 7.2295 kJ per kilogram Kelvin. At 40 bar, the saturated temperature is equal to 250.3 degrees Celsius, and we will convert it to Kelvin, which will add 273 to 250.3, which equals to 523.3 Kelvin. HF is equals to 1087.4 kJ per kilogram, and the HFG is equals to 1712.9 kJ per kilogram. SF is equals to 2.797 kilojoule per kilogram Kelvin. SFG is equals to 3.272 kilojoule per kilogram Kelvin. Properties of steam at 0.1 bar. HF is equals to 191.8 kilojoule per kilogram. HFG is equals to 2392.9 kilojoule per kilogram. SF is equals to 0.649 kilojoule per kilogram Kelvin. SFG is equals to 7.02 kilojoule per kilogram Kelvin. S1 is equals to 6.5125 kilojoule per kilogram Kelvin. S2 is equals to SG at 40 bar. The superheated temperature is equal to 332 degrees Celsius. Enthalpy 2 is equal to 3047.18 kilojoule per kilogram. Entropy 3 is equal to Sg at 0.1 bar. Entropy 4 is equal to entropy 3, which is 7.2295 kilojoule per kilogram Kelvin. We will now find the missing value of X4, which is the quality of steam at turbine exhaust. We now substitute the values of S4, SF4, and SFG4 that is already given. Therefore, it becomes 7.2295 equals to 0.649 kilojoule per kilogram Kelvin plus X4 multiplied to 7.502 kilojoule per kilogram Kelvin. The result is X4 is equals to 0.877. Now that we found the value of X4, we can now find the value of H4. H4 is equals to HF4 plus X4 multiplied to HFG4. Therefore, it is equal to 191.8 kilojoule per kilogram plus 0.877 multiplied to 2392.9 kilojoule per kilogram. Therefore, H4 is equal to 2290.37 kilojoule per kilogram. We will now find the value for the cycle efficiency. The formula of efficiency is H1 minus H2 plus H3 minus H4 divided by H1 minus HF4 plus H3 minus H2. Then, we will substitute the given values in each variable, and it becomes 0.4426 multiplied to 100. Now, we have the efficiency, which is 44.26%. Then, we will find the value of the steam rate, which is equal to 3,600 divided by H1 minus H2 plus H3 minus H4. Then we will substitute the given values in each variable, and the steam rate becomes 2.16 kilogram per kilowatt hour. That's all for today. Thank you.